Hello students, welcome back. So now we are going to be talking about overfitting. Overfitting, it happens when your model, it learns your training data pretty well, but it performs very bad on your unseen data. Generally this unseen data, that's your test data right here. So in this case, your training error is going to be very low, but your test error is going to be very high. So if you compare your performance on the training versus the test data, you are going to see that there is a big gap, and generally that is a sign of your overfitting. So what are the main causes of overfitting? Well, number one, your model may be too complex. This is one of the most common one. For example, you could be using a high polynomial degree. You could be using a large neural network. So this is going to have a lot of neurons in it. Another reason could be you're using too little of your training data. Your training data is very small. In this case, your model will memorize your samples because your training data is very small. And the third reason could be that's because you could have too many features. When your number of features are way greater than the number of samples. In this case, your model, it tends to find fake correlations. So now the first thing I do, I import my diabetes data set right here. Then I'm also importing train test split. This will be responsible for splitting your data into training and testing. Also importing polynomial features, standard scalar, pipeline, linear regression, and my R2 score. This is the metric I'll be using. So I'm loading my diabetes. That's my first thing I'm doing. Separating my X, separating your Y. X is your features. This is your independent variable. Y is your dependent variable. And I want to see how my first three independent variables look like, how my first three features look like. And I also want to see how my first three target value they look like. So these are my first three values for X right here. And this one is the first three values for their first three corresponding values for these X's. And now what I'm doing, I'm splitting my data. In this particular instance, I'm splitting my data into 50-50. And I intentionally do this thing just to show you overfitting. So in this case, I'm specifying my test size as 50%. And then I create my overfit model. I'm using a pipeline. So creating a standard scalar, I'm using polynomial feature right here. So in this case, I'll be specifying degree equal to 2. And my model is going to be linear regression model. And then I train my model right here. After I train my model, I ask it, I give the model the X train. This is the X train, this is the actual data. I'm also asking it to make a prediction. I already know what the value should be. So I'm asking the model now to make a prediction. Also, I'm giving the model the test data right now, and it's giving me a prediction right here. So now what I do, I use the R2 score and I compare the Y train with the Y train predicted. This is the training data, actual value, and this is the one that model predicted. I'm comparing the value. I want to know the R2 square. And then I also do the same thing with my test data. So I'm giving it the predicted value. Sorry, this is the predicted value, and this is the actual value for the test data set. And I'm giving it to the R2 score function. And that prints out my R2 score right here. And you can see that your training is very well. It's like 0.64, but your testing is 0.35. There's a big difference between your training and your testing for R2 score. So there are a lot of methods available to find overfitting, and one of the most common one that is used would be this. You find the difference between the training and the test score, and this is exactly what I'm doing. I'm actually writing a little program, and I'm checking if the difference between my training R2 score and the test score, let's say the absolute difference is more than 0.10, I'm going to say overfitting. I'm just picking up this number, by the way. Another method I can do is I can perform cross validation score. So in cross validation score, the sign for overfitting is this. If you have a very high train score and lower CV score, that would mean that your model is overfitting. So in this case, I'm calling cross validation score, giving my model, give your X, give your Y, supply your CV equal to 5, and then you also supply your scoring equal to R2 square over here. And I'm printing out the scores. I'm also printing out the scores mean value, and then I'm printing out the the training score value. I'm also printing out the CV score value just to see how these two values they do. And you can see that your training score is this and your CV score is this. Big difference from here to here. So I'm writing a little code over here that actually checks if your training score minus minimum score is more than 0.10, then it's going to print out overfitting. In this case, you can see it is more than 10. The difference in this and this is more than 10.